And because it involves a fair bit of writing, there's bound to be a mathematician that comes along that says, I bet you we could do this with a little bit less writing. And they came up with the following method, which I'm not going to explain. You're just going to watch and see if you can figure. I will explain it eventually. Don't be like, oh, great. Today's lesson is just like, have no idea what's happening. And my teacher just said, good luck. Right? No. I will explain it eventually, but watch what happens and see if you can figure out where the numbers come from. I'm not going to do it super fast, but your job is to see if you can recognize some patterns. So, this is what is going to happen. I'm going to write it like this as a start. You notice the answer I circled is the same as the answer we got with long division. Whew. But a lot less writing. First question is, did anybody see where the blue numbers came from? Okay. What's one thing that's different with the blue numbers than the long division? Besides the fact that I don't write any X's. Okay? Method is ingenious in a lot of ways. Okay? Notice that these numbers, the 3, the -1, the 0, the 3, and the -20, they were the numbers in the right order. So the order is important, just like long division. And I had to add the 0, just like long division. So the setup is the same as long division. Just we have some numbers, but we never write the variables. So the mathematician's like, well, if we want to make it a shortcut, if we know that we've written everything in order, and we've included the zeros, we can just forget about writing the exponents and the variables with. Second thing that's a little bit different is that this -2 came from this. In long division, you write x plus 2 because that's what you're dividing by. And in long division, you're forced to subtract every time. And what's ingenious about this method, what this method we're going to find out is called synthetic division, is by, instead of putting the +2, adding the negative or the opposite sign here already, did you notice that I got these numbers in the bottom by adding instead of by subtracting? And it seems small, but I guarantee you that you make a ton less mistakes adding than when you subtract. When you subtract with negatives, it just happens, you make mistakes. Adding, people make less mistakes. So in each of these columns, I just added up the numbers, whereas in long division, you always had to subtract. You get the same numbers every single time. In synthetic division, they noticed that this number always matched up with this first number, and this method is only going to work when you're dividing by x plus something or x minus something. So this new technique that we're learning, that's called synthetic division, doesn't mean that long division is completely no longer, wow, I can't, there we go. doesn't mean that you're no longer going to use long division. So if we highlighted it here. This is called synthetic division, but it's only going to work, at least we're only going to use it in this form. There's been mathematicians that have created shortcuts for other forms as well. Perfect, it's great, but we're only going to use it for when you're dividing by x plus something or x minus something. And the patterns that you notice are the steps. The first thing you're going to do is write out the opposite sign. If you're dividing by x minus 2, you're going to write a positive 2. If you're dividing by x plus 3, you would write a negative 3. So you're going to write the value on the left, and then use the coefficients to write numbers on the right. If there's a variable missing, we have to include zeros. We have to make sure things are in the right order. So just like long division, we shouldn't rush, because it's not hard, but it's easy to make a mistake when you rush. You always bring down the first number. And after you bring down the first number, and I often show this by actually even drawing an arrow saying I brought that number down, then the number that's at the bottom gets multiplied by the 2. So 2 times 5 is 10, and you write 10 there. And then you add at 17. Then we repeat this process, but now we have 17, so we go 2 times 17, that's 34, and then we add. The last number is always your remainder. And you can work backwards a couple of things. Some students go, if I had a 5x squared to start, that means if I divided by x, this will be an x. So this will be 5x plus 17, remainder 30. Other students start with the remainder, then this is the constant, then this would be an x. The next one would be an x squared if there was more numbers, and so on and so forth. And this is called synthetic division. And what's nice about it is that it is a lot faster than long division. So in synthetic division, first of all, we look at what we're dividing by, x plus 2. So we are allowed to use synthetic division because it's x plus something, x minus something. I am going to put brackets around this and right away say let p of x equal that so that my division statement is easier to write. We do our setup, there's going to be a minus 2 out in front. This is in order and nothing's missing, so I don't have to add any zeros, and I just write the coefficients. So there's your setup for synthetic division. Just writing the coefficients, making sure that we're still doing our setup rules, that it's in the right order, which it was, and that there are no terms missing. We don't have to add any zeros in this case. Once you have it set up, you always bring down the first number. And once you have a number on the bottom, it gets multiplied by the number on the left. So negative 3 times negative 2 is 6. That number gets placed there. And we add. Negative 2 times 8 is negative 16. And we add. Negative 2 times negative 13 is positive 26. And we add. And negative 2 times 22 is negative 44. And we add. The division statement will say p of x, nice, we don't have to rewrite that whole thing because we said that at the beginning, is equal to our divisor, x plus 2. Our quotient is listed here along with our remainder. So since we started with an x to the 4, this will have an x cubed. Then 8 x squared minus 13x plus 22. There's a Dairy Queen statement. Crazy thing is in the old curriculum, they taught long division in grade 10. So what we did in the first part of this lesson used to be in grade 10 math. And they didn't teach synthetic division until grade 11. You only had to wait one day to get the shortcut. Meanwhile, I used to teach it and be like, these poor grade 10s, all year, I'm not allowed to tell them that there's a shortcut for this. And then in grade 11, I'd be like, oh, by the way, we could have done this so much faster. Question?
Where does the negative 2 come from if it's x plus 2?
So with synthetic division, that's always the opposite. So if it's x plus 2, we'll write minus 2. If it was x minus 3, you would write plus 3. And it's the opposite which allows us to add instead of subtract. So one of the biggest difference between synthetic division and long division always had subtract stuff. Synthetic division has adding stuff. Adding is easier than subtracting. So by doing this little change at the beginning, making it opposite, allowed us to add instead of subtract. Synthetic division would work if you had the same side but decided to subtract. So if I had a 2 here, right, then I bring down the negative 3, this would be negative 6, and then I have to subtract 2 minus negative 6 would still give me 8. But you're going to make so many more mistakes, so this just makes it easier. Okay, questions for practice on this one? 8, 9, 11, and 12.